Hello everyone, welcome to the channel Unknown Physics. Today I am going to continue my thermodynamic problem series. In my previous video I have done 4 problems and given the 5th one as a task to you guys. If you have not watched that video, I am giving the link in the description. Please do watch it and continue. So before going to the problem, I want to apologize guys because in my previous video I have not mentioned the keyword for this question adiabatically. So our fifth question is, when an ideal monatomic gas is expanded adiabatically from initial volume V0 to 3V0, its temperature T0 to T, then ratio of T by T0 they are asking. So I have given 4 options for this question. So let us get into the solution. We know that for adiabatic process P V par gamma is equal to constant, and by rearranging we get T V par gamma minus 1 is equal to constant, P par 1 minus gamma T par gamma is equal to constant. And in the question they have mentioned that it is for a monoatomic gas. For a monoatomic gas degree of freedom is 3. So gamma will be equal to 1 plus 2 by F. So gamma will be equal to 1 plus 2 by 3. So our gamma value will be 5 by 3. Substituting this in the previous equation and rearranging and doing all the mathematical calculation, you get the ratio of T by T naught as 1 by 3 whole power 2 by 3. That's it. It is easy, right? So our next problem. For a diatomic ideal gas at room temperature, what fraction of the heat supplied is available for external work if the gas is expanded at constant pressure at constant temperature? So let us look for constant pressure. Read the question carefully guys. It is for a fraction of heat supplied is available for external work. So it should be delta W by delta Q. Be careful in this. So from first law of thermodynamics, delta Q is delta U plus delta W. And for delta U we know NCV delta T. To find CV you need gamma value. So CV will be equal to R by gamma minus 1. You get your CV value. Here our CV value is 5 by 2R. So R delta U will be here 5 by 2 NR delta T. I am replacing the rest 2 terms in terms of NR delta T by the use of ideal gas equation. So by substituting all this, finally our delta W by delta Q will be equal to 2 by 7. Next is for constant temperature. At constant temperature means it is an isothermal process. So by substituting all these, you will finally get it as delta W by delta W, that is 1. So your fraction of delta W by delta Q here it is 1. Just go through it guys. It's very easy. It's very simple. And let us go to our next problem. A system is taken along the paths A and B as shown. If the amount of heat given in this process are delta QA and delta QB respectively, then they are asking. Actually this is an MCQ. I am not given the options. So look here, delta U is same for both A and B because the initial and final states are same for this process. So the work done by A will be greater than the work done by B by that area. So delta QA will be greater than delta QB. Our next problem, if the equation of state for a gas with internal energy U is given, PV is equal to 1 by 3U, then the equation for adiabatic process. So they are asking the equation for adiabatic process. So for adiabatic process we know PV par gamma equal to constant, and for an adiabatic process D par Q will be equal to 0, and for an isochoric dW will be 0, and for isothermal du will be equal to 0. So du is equal to minus dW. So we know that from the question U will be equal to 3 PV. Substituting this and differentiating, finally we will get 4 PdV plus 3 VdP. It's just by differentiating we get this as step. And our next step is to divide this equation by PV. So we will get 4 dV by V plus 3 dP by P equal to 0. So on integrating dV by V, that is 1 by V of dV is nothing but ln V. So 4 by 3 ln V plus ln P will be equal to ln C. So our final answer is PV power 4 by 3 is equal to constant. Our next question, the internal energy of a system is given by E is equal to B S cube by Vn, then the temperature of the system. So they are given the internal energy, they are asking the temperature. We know from the first law of thermodynamics dQ is equal to dW plus du. Here they are given U in terms of E. And we know dQ is equal to TdS. Here our volume is constant, so our work done is 0. So T will be equal to dE by ds. So finally T will be equal to 3B S square by Vn. That's it for the day guys. So I'll be doing a lecture series and problem series alternatively hereafter. So still then keep practicing, keep revising the formulas. Bye bye. Have a nice day everyone.